Hello everybody, I hope you're all doing well. We're looking at question 23 in this video from our 2012 grade 7 Gauss. The number n is the product of all positive odd integers from 1 to 99 that do not end in the digit 5. And that is n is 1 times 3 times 7 times 9 times 11 times 13 all the way up to times 97 times 99. The units digit of n is... Okay. So the reason they say no fives is because that would make this question really obvious. The answer would be 5, because any odd number times 5 ends in 5. Okay? But they've made it more interesting now. Now we want to talk about the units digit. And you can start grabbing your calculator and multiplying these out, but you're going to be multiplying how many numbers? 40 numbers? That's going to be a lot of numbers to multiply out. You're probably going to misclick and hit the wrong button. And it may turn out, quite likely, that this number is too big for your calculator's display. So what do we do? If I can't use my calculator, I'm nothing, right? Wrong. Okay? You're better than your calculator. What we can do is we can fall back on regular old math. Okay? We can look for patterns. Okay? And what are they asking for? They're asking for the units digit. Okay? Is there any quick way to find units digits for products? Okay? So for a moment, I'm going to have you consider 12 times 13. Okay? What is that? What is 12 times 13? You work it out, it's 156. What's 12 times 3? 36. What's 2 times 3? 6. What's 22 times 13? You'll get 286. Okay? What's 2 times 33? 66. Focus in on the units digits. Every single time I've got a 2 and a 3. And every single time I get a 6. Okay? It turns out, and you can examine this better with modular arithmetic, so I'll make a little note here. Modular arithmetic, which I'm not going to go into, but basically it's doing math, but looking at remainders. Okay? And if you're interested in that, I'll see if I can rustle up some resources, maybe make some special modular arithmetic videos, or point you in the right direction for something, or you can just look it up on your own. Okay? But what's really nice when it comes to this sort of stuff is the units digit of a product is determined only by the units digits of the numbers you're multiplying. So the fact that it was 33 has no bearing on the 6 at the end. It matters for the 60 part of it, but not the 6 at the end. Okay? You get a 2, and if it ends in 2 and 3, the product's going to end in 6. So how does this help me? Well, it means this big, giant product here, when we multiply it all out, if we're just concerned with the last digit, the units digit, I don't really care about the 1 and the 11. The 10 and the 10's digits here don't matter. And this becomes very nice. Now we're just multiplying 1 times 3 times 5 times 9. How many times? So it would be zeros. These are the ones that would have had 1, 9. So we're really doing 1 times 3 times 7 times 9 10 times. Multiply that out by itself 10 times. Or, you could say raise it to the power of 10 if we're very comfortable with exponents. Okay? So we're going to do this 10 times. And this is something that's a lot easier to do with a calculator. And if you wanted to, just press the buttons. 1 times 3 times 7 times 9, 1 times 3 times 7 times 9. This number would probably fit on most calculators. I'm going to grab mine real quick just to check. 1 times 3 times 7 times 9. Oh, actually, it's too big for my calculator display. So even with this simplification, we're a little stuck, right? Okay. Well, what's 1 times 3 times 7 times 9? Well, no one cares about the 1. It doesn't do anything. 7 times 3 is 21, times 9 is 189. So really we're doing 189 times 189 times 189 10 times. But again, what do we care about? The units digit. So the 1 and the 8 don't really matter. The hundreds digit and the tens digit, no one cares. Okay? So it's just 9 times 9 times 9 times 9. And that one, let me check before I make a bold claim, can be done on your calculator. And it ends in a 1. Although, let's say for our I can remember my calculator. Okay? It happens. How would I handle this? Could I still do question 23 without my calculator? Well, we've been able to do it without a calculator so far. Okay, 2, 4, 6, 8, 10. So there's 10 nines. The units digit of this will be the same as the units digit of their capital N that they were asking about. Now these two nines make an 81, an 81, an 81, an 81. So if I multiply the pairs of nines, what I'm really doing is multiplying 81 5 times. But again, we just care about the units digit. So we're really doing 1 times 1 times 1 times 1 times 1. And that one, everyone can see ends in a 1. Okay? So we get this great simplification when we're just looking at units digits, which are really just remainders when you divide by 10. But we can see our answer must be A. Units digit of this big product my calculator couldn't even hold after a couple simplifications still must be A. And we worked that out by recognizing the pattern of the 1, 3, 7, 9 and being able to experiment. What really impacts my units digit when it comes to products? And it turns out the units digit of the factors. Okay? So that was question 23. We're now definitely halfway through part C. We've got 2 more questions to go. Up next, question 24.